I did not bring my lecture.
不是519吧？
今天不是5月19日吗？对呀、昨天没签吗？
嗯。
Okay, any questions? No? Or so first of all, just let me know immediately. Do you want me to leave? Do you want me to review the class material of last semester or not? Basically, I can do that. And if it helps your understanding level, I can do that. Yes?
Yeah, do.
Sure.
Please,
Not a
please,
problem.
Please.
Basically, this one is review and study again,
Please,
and
please.
if it helps your understanding level, don't hesitate. Okay?
Please.
So in case of mathematics, you know nothing, but you act as if you know something. That will be a problem. Okay? I know that you guys are professors and do not like becoming a student again, but anyway, please study. Okay? Then I will compare a couple of things about the OLS and the mathematical version of it. So in this case, let's do the OLS from the basic. Or do you want me to review the concept of variance again?
Sure.
Okay. Then let me just repeat last semester's class. The most important thing in statistics is variance. Okay? The concept of the variance, this is the measure of data dispersion. What does it mean is everybody knows something about average, or in statistical term, mean. Okay? When there's some randomness, we call average as the mean. This is relatively simple. The concept is quite straightforward. When you have two data points, my general example is 1 and 3. Okay? You have two data points. And then the concept of average is quite simple. 1 plus 3 divided by 2. Okay? You add them up, divided by number of observations. Then this is 2. In terms of geometry, you have 2 points, 1 and 3. The average is exactly in the middle. Okay? This is the concept. In terms of geometry, you have observation number 1, observation number 2. Then what is the average? Somewhere in the middle. Okay? So this one becomes the average or the mean. Okay? Then the question is, what is the measure of data dispersion? In other words, we can think about something different. In this case, 0 and 4. Okay? Then what is the average? 0 plus 4 divided by 2, that is 2. In terms of geometry, here is average 2, 0, and 4. Oh, I have to draw it longer. 0 and 4. This way. Okay? These two data sets, the number of observations are same. 2 observations and 2 observations. The average is the same. 2 and 2. But they are different. Okay? How different are they is related to variance, the measure of data dispersion. For example, average is the same. This is the middle point, but distance from the mean, this one is relatively shorter than this one. Okay? They are more widely dispersed. This one is more compactly, narrowly dispersed. That's the difference. Even though the average is the same, this one is compactly distributed, this one is widely distributed. In statistics, we want to measure that concept. That concept is variance. So in this case, this is the distance. In terms of distance, this is 1, this is 1. Okay? In terms of distance, the length between these 2 points is 2. The length between these 2 points, that is 2. Okay? So this one, we want to measure this kind of length in a systematic way. That is the concept of the variance. The problem is that in terms of length, this is 2. But when we make some kind of measure, we may think this one as -2 and -1. Okay? In terms of length, this is 1. But in terms of the difference between 1 and 2, that kind of concept is called as mean deviations. Mean means average. Okay? Mean deviation means how different or how far or what is the difference between the mean and actual data point. Okay? So mean deviation in the first example is 1 minus 2. This is mean or average. This is first mean deviation. The first mean deviation is -1. Okay? Then the second mean deviation is 3 minus 2. This is second observation. This is average. The second mean deviation is +1. Okay? In terms of length, this is 1 and 1. But when I calculate mean deviation, that is observation minus mean, how far or how different you are from the mean, in terms of number, this one becomes -1 and +1. Okay? So the good property of mean deviation is that when you sum this up, sum of the mean deviation becomes 0. Okay? The first mean deviation is -1, second mean deviation is +1. When you sum them up, it becomes 0. Okay? This is one good property of mean deviation. But the problem is that when you sum them up, this kind of mean deviation, for the second example, this one, first mean deviation is, what is it? 0 minus 2, that is -2. Second mean deviation, 4 minus 2, that is +2. Okay? This number is twice bigger than this one. This number is twice, 2 times bigger than this one. Okay? So in terms of measure of data dispersion, this data set is twice or 2 times further than this data set. But when you sum up the mean deviation, this one is still 0. Okay? So we don't like this kind of property. So one way is just calculate the length. When you simply calculate the length, or if you just calculate the absolute value of -1, this one becomes 1. Okay? And absolute value of 1, 1. Absolute value of -2, that is 2. Absolute value of +2, that is 2. in this case, when you sum this up, the number is 2, the number is 4. So you can see that the measure of data dispersion in this one is twice bigger than this one. Okay? So that is one way of measuring data dispersion. This one is more intuitive. Okay? So the length. Okay, this is mean deviation, but forget about this negative number. Only calculate the length. Let's calculate the absolute value of it. The problem is that we cannot do calculus on this absolute value. You cannot do derivative on this value. This kind of absolute function is something that looks like this. This is not continuous. This is continuous, but it is not differentiable. So mathematicians, they don't like this. Okay? So this one is more intuitive in terms of measuring data dispersion. But the problem is that we cannot use calculus, derivative, those kind of things in this kind of way. This kind of, the applied version of this kind of absolute value is very limited. That's why people do not use this kind of measure. Okay? If you do not like the concept of variance, the simple thing is that why don't we use this kind of simple difference? The thing is that it is not differentiable. You cannot use calculus at all. So people do not use this kind of way. What they use is that the problem is here is negative sign and here is positive sign, and when you sum them up, this one equals 0. That is the problem. Okay? So what people use is they square it this way. Okay? Instead of mean deviation, they use mean deviation square. This way. Mean deviation square. Oops. Mean deviation square. This way. Okay? Then when you square it, what you get is value number 1, 1. When you sum this up, this one becomes 2. Okay? Then when you square this one becomes 4 and 4. When you sum them up, this one becomes 8. Okay? So that's why we square it. In case of something like x squared, you can do calculus or derivative. They are anyway differentiable. Okay? So because we want to do some kind of derivative, calculus, those kind of things, instead of taking absolute value, we take square. Okay? That's why we use squared mean deviation. We don't like this kind of negative value, so square it, make it positive. Why we are not using the absolute value? Because in case of absolute value, it is not differentiable. But in case of square, it is differentiable. So people decided to use this kind of squared mean deviation. Okay? Then there are two values. We are trying to calculate the average. Average of squared mean deviation, 2 observations. Let's divide it by 2. Okay? Then you will get number 1. 2 observations, sum them up, divide it by number of observations. The variance becomes 4. Okay? So in case of absolute value example, this one is twice. The length was 1, length is 2 here. This was twice bigger in terms of measure of data dispersion. In case of mean deviation square, because you squared it, this is 1. In the previous example, it was twice bigger than this one. In this case, this one is 4 times bigger than this one. Okay? So if you remember the standard deviation, you squared it, then take square root of it. You inflated it by squaring it, then deflate it by taking square root. Then you will get number 2 here. Okay? Now this one is this data set and this data set. This data set is twice or 2 times more dispersed compared to this one. Okay? So that is the logic behind mean deviation squared. Okay? So in case of in terms of the variance, what I use as a definition is the average of squared mean deviations. This is the concept. Okay? You have some kind of mean deviation, square it, calculate the average. How do you calculate average? Sum them up, divide by number of observations. Okay? And variance is almost everything in statistics. Really. You need to understand this concept. That's why I am teaching it again and again and again and again. So this is probably just enough. And if I teach something called as standard deviation, standard deviation is square root value of variance. This is concept. Why do we use the square root value? Because in case of variance, because of the squaring, the value is inflated from 2 to 4. Okay? Then we need to deflate it. So this is the concept. But in most of my case, what I use is this one, the concept of variance. Okay? So this is the measure of data dispersion in terms of mathematical definition, the average of squared mean deviations. We square it to remove the negative sign. Okay? Then calculate the average. Then it becomes the measure of data dispersion. Question? Okay. So variance, this is the most important. Okay? Then the next thing that I need to teach is something called OLS. This one is called as ordinary least squares. The concept is, it is the, what is it? Simplified version of ordinary least squares. We usually call it OLS. Okay? This one is basically line fitting. Okay? Then how do we do line fitting? We have 3 observations. Try to find which one is the best. Okay? Maybe this one or maybe this one. Is this one is better line for this one, or what is this one? The criteria for this kind of line fitting is minimizing squared residuals. Now you see something called squared here again. Why? Basically, if you think about this one, just think one line, then this is distance. Okay? But this one, we may think positive value, negative value, negative value. When you sum them up, just like mean deviation, it becomes 0. Okay? Then, to make the negative thing into positive, we need to square it. Okay? So, OLS, the objective function is minimizing squared residuals. This kind of residual is the distance between estimated point and the real point. Sometimes positive, sometimes negative. Just like mean deviation, when you sum them up, it becomes 0. Then how do we compare those kind of things? Square it, sum it. When it has the minimum number, we think that it gives the best prediction, or it will give you the best line fitting. Okay? That is the, big picture of the OLS. We have data point. We are trying to find one kind of trend line. Which line is the best? The line that minimizes the sum of squared residuals. Okay? Residual number 1, residual number 2, square them, sum. Okay? So that is the main purpose of OLS. Then here in OLS, we think something differently. What we really do is we observe this kind of data and try to find the line. However, when we want to do this kind of things, we change our logic. What we think is we assume a data generating process. That is yi equals alpha plus beta xi plus epsilon I. In the real world, what we do is we observe this one and try to find the best line. But in theory, what we do is there's one data generating process. So this is the real data generating process, and the difference is error 1, error 2, and error 3. Okay? So what I need to get is this value, and this value, and this value. But because of the error, you get something slightly lower, this time something slightly higher, something slightly lower, that way. Okay? Then, when we assume this kind of data generating process, we assume this error term is, for the strong kind of assumption, let's make it normal at this time. It has normal distribution, mean 0, variance of sigma squared. Okay? What this one means is that here is negative error, positive error, and negative error. When you sum them up, just like mean deviation, the sum of all the errors becomes 0. Okay? That's one thing. When you add up the mean deviations, it becomes 0. We also want to assume that kind of thing. The problem is that what is the data dispersion of error term? Okay? Sometimes this one compactly or closely distributed. Or you may have this one. This one is more widely distributed. Okay? So in terms of measure of data dispersion, the measure of data dispersion is variance. Okay? If the variance is small, you will see this kind of data set. If the variance is large, you will see something like this one, this one, this one. Okay? So this one measures the data dispersion of error term. If this sigma square is big, then you will see large dispersion of error term, like this. If this sigma square is small number, that means that you will see small dispersion of error term. But we have no idea about this value, but we assume that mean is 0, it is dispersed at this bad level of variance. Okay? So that is our assumption. We have some data generating process. The value that we need to get is this one, and this one, and this one. But because of error, we get this point, and this point when the variance is small. When the variance is big enough, we will get this one, and this one. They are quite big variance. Okay? Okay. Then how do we define the residual? This part may be familiar. We define yi minus alpha minus beta xi. We define it as an error or residual. Okay? This part is called as residual or error. The difference is error is statistical concept, residual is observed value. Okay? So this one is epsilon I from our data generating process. This one. Okay? yi minus alpha minus beta xi, that is epsilon I. This is error, but error and residual, they are very similar. Error is statistical concept that is distributed in this way. Residual is observed values from the error. Okay? Then our objective is minimizing sum of squared residuals. Error and residual is very similar. yi minus alpha minus beta xi, this is residual. We need to square it, sum it, and minimize it with respect to alpha and beta. Okay? This is the purpose of OS. We call it, this one as objective function of OLS. OLS is trying to minimize this objective function. Okay? Question? How do you do it? How do we do this? We use partial derivatives and chain rules. Do you remember what is partial derivative? Do you remember the chain rule? Okay, this part. But let me briefly review that again. Okay? So first thing, the derivative. This one is something called as calculus, or I generally call it as the slope of the line, or curve. But anyway, this one is relatively simple. When you have y equals x squared, okay, you can do derivative or calculus of it. Okay? dy dx, this is my favorite notation. Okay? Basically means that do the derivative. Okay? Then what is the result? Y equals x squared. When you take the calculus, what is the result? Guys, please. What is the derivative of x squared?
2x.
Yeah, 2x. Not that difficult. Any problem? Okay? Y equals x squared. When you take the derivative with respect to x, what is its derivative? 2x.
Yeah.
Do you get it?
Yeah.
Any problem? Do I need to teach it? If you want me to teach it, I can teach. Okay?
I didn't come last semester, so this part is not that familiar for me.
Okay. So then let's talk about the derivative. Okay?
Yeah.
So derivative is basically something about the slope.
你不用管，就看多几次方，你就把它方程型的系数。
后边那个再减2.1，
对，它会是0吗？没有。
对，
或者
而且
所以没有常数项，
对
没有常数项。We'll explain to.
I don't know. Basically, if he wants me to teach it again, I can do that. Don't worry
Yes,
about
please.
that. Yeah.
这个过程很复杂，直接记结果。
Don't worry about that. Okay? So think about the slope of a line. Okay? We can think about y equals 2x. This is x, this is y. When you think about y equals 2x, when x equals 0, y equals 0. When x equals 1, y equals 2. When x equals 2, y equals 4. 0, 1 and 2, and 2 and 4. When you connect it, this one becomes your line. Then what is the slope of it? Slope is 2. Okay? When the x increases by 1, y also increases by 2 all the time. This one is called as the slope of the line. Okay?
Yeah.
In this case, this kind of slope of line is related how steep or how flat the line is. In case of line, this is simple. Okay? Then the problem is slope of the curve. When you have a something like curve like this, okay, then how do we calculate the slope of it? When you pick 2 points, the slope will be this way. Here, you have 2 points, the slope will be something like this. That is the problem of the curve. In case of curve, slope is changing. And it is very difficult to calculate the slope of a curve. Okay? So what we do is, to calculate slope of the curve, we use the concept derivative or calculus. Okay? So the most famous example is y equals x squared. Okay? In this case, how do you calculate the slope of it? In this case, when you compare these 2 points, okay, the way that you calculate is, this one is the second point, this one is the first point. Okay? Then the way is you take the difference between the second point and first point in terms of x values. Okay? And then here, in terms of y values, you calculate the what? Oh, no, not this way. I'm sorry. This one is the second point is 1. The first point is 0. Okay.
Yes.
And the second point in terms of y value, that is 2,
2 and 0.
0.
Yeah.
Then you will get slope of 2.
Yes.
Okay. That's how you calculate the derivative. Okay.
Yes.
In this way, we use the same thing. So we think about the first point, that is, one is x1, another is x2. Okay?
Yeah.
How do we calculate this kind of the slope in case of the curve? x2 minus x1, y2 minus
Y1.
y1. This is how we calculate derivative.
Yeah.
Okay? Then here we change this kind of notation slightly. The way that we change our notation is that x1 equals x1, x2 equals x1 plus h. Okay? That means that when you have this kind of thing, here is x1, here is x2, x2 is x1 plus h, this distance is h.
Yes.
Okay?
Yes.
Then when the h becomes smaller, when this h is getting smaller and smaller and smaller and smaller, then the distance between these 2 points is getting smaller, 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 and smaller.
Yes.
Finally, when their distance is very, very, very small, then it becomes something called a tangent line. Okay? That is the concept of calculating slope of a curve. So you have 2 points. First point is x1, x1. Second point is x2, x1 plus something small. And make this one as small, smaller, 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 makes it almost 0. Then it will become a tangent line. And slope of the curve is basically the slope of the tangent line. This tangent line means that this curve and this line, they cross only at one point. Okay?
Yeah.
Then how do we calculate this kind of thing? The way is the same. Here, what we do is, what we have is y equals x squared. This is our function. Then for the point of x1, the value of y equals x1 squared. Okay? This is our point number 1.
Yes.
Our point number 2 is x equals x1 plus h. Okay? Then the value of y equals x1 plus h squared. This way. Okay? Then how do you calculate this one? y2 is x1 plus h squared minus y1 x1 squared divided by x1 plus h. This one is x2, the second x value, minus x1. x2, x1, y2, y1. What remains here is
H.
h. Okay? If you calculate this one, do you know this one? x1 square 2x1h plus h squared. Any problem?
No.
Okay. Then x1 squared plus 2x1h plus h squared minus x1 squared. This part.
Yeah.
Okay? Then what remains here is h. This x1 squared and this x1 squared, they are cancelled out. 2x1h plus h squared. Then what you get is this h and this h cancelled out. 2x1 plus h squared h, just h.
Yeah.
Okay?
Yeah.
Then what I told you is that in this case, we make h goes to
0.
0. Then this one disappears.
Yeah.
Okay?
Okay.
Then at the point of x1, okay, x1 plus h is getting smaller and smaller, then this point also converges to this one.
Yes.
What is the slope of the tangent line?
2x.
2x1. Okay?
Yeah.
So that is the concept of derivative. Okay?
Okay.
So when you have something like y equals x squared, the notation for the derivative is dy dx. This is notation. I prepare this type of notation. That means what is the derivative or slope of this line? That is 2x. Okay?
Yes.
So in case of x squared, derivative is this one. In case of line, y equal 2x, what is the slope of it? Just this number. Okay?
Okay.
Okay? So when you take derivative of 2x, dy dx, that is
2.
2. Okay? When y equals x squared, derivative of it is
2x.
2x. Then y equals 2 times x squared, derivative of it is 2 times, what is derivative of this one?
2x. 4x.
Okay?
Okay.
This is slope of the curve or something called calculus or derivative. This is the most important part. Okay?
Okay.
Then, what I need to teach is the partial derivatives. In case of partial derivatives, we can think about something different. Y equals x squared, you have y and x. Okay? One variable here, one variable here. Okay? In this case, we can use general derivative. But what happens? Y equals a squared plus b squared. Here you have one variable. But here you have
2.
two variables. Then we need to define something called as partial derivative. In case of partial derivative, almost everything is the same with general derivative. But we use this kind of notation. Let me simply change it. Yeah. Let's make it C. Okay? That's more convenient. Then in this case, we use the notation of derivative this way. This one is called as round. Okay? Round C, round A is possible, and round C, round B is also possible. Because this part has two variables, you can take derivative with respect to A And you can take derivative with respect to b at the same time. Okay? When you take the partial derivative of c with respect to a, forget about b. Then what is the result?
2a.
2a. When you take partial derivative with respect to b, forget about
a.
a. Then what is the result?
2b.
2b. Good.
rb.
Okay?
Yeah.
This is partial derivative. Then something a little bit more complicated. Let me delete this part. When c equals, let me change it. When d equals e square and f square, something like this. Okay? Then we can think about round d, round e. Okay? Then f, forget about f. This is just simply a number. Then what is the result?
2e.
2e times f squared. Okay? This one's this time something like number. Oh, I just deleted.
Yes.
Y equals 2x squared.
Yes.
Then you multiply 2 times 2x. Okay? This 2 is the same as, in that case, f
f square.
squared. Okay? So this one is not changing. So this one is the something else. There's no change in this one. Then when they are added, a is changing but b is not. Then what's the slope of b? 0. Indeed, this one is this one. But we just skip that. Here, this one is multiplied as a number. So we cannot remove this one. This one is something like 2 or 3, some kind of number, this way. Then round d, round f.
2f multiplies e square.
Good. This is partial derivative.
Okay.
Okay?
Okay.
So that's the concept of the partial derivative. Next thing is chain rule. Chain rule. The next one is something like what happens y equals 2x plus 1 square. This way. When y equals 2x plus 1, what's the slope of it? What's dy dx?
2.
2. Plus 1 is not changing, 0. So we can forget about this one. Okay? When y equals x squared, what is dy dx?
2x.
2x. Here, both of them are combined. Okay? Here is 2x1 plus 1, and here is x squared. So when two functions are combined, we call it compound function. But anyway, how do we do this kind of chain rule? This kind of derivative. Okay? And the way of doing this one, we call it chain rule. Okay? So in this case, we can think about it in two ways. We define something else, y equals f of x, that is 2x plus 1. Okay? Y is the function of x, okay? That is 2x plus 1. So sometimes we write it y equals 2x plus 1 or f of x equals 2x plus 1. Then of course, y equals f of x equals 2x plus 1. That makes sense. This is just notation. Okay? Then when we define f of x equals 2x plus 1, okay, this one, we can write this one, okay, y equals f of x
Square.
square. Okay? Then we are trying to take the derivative dy into dx. Okay? But the problem is that here is x, here is f of x. So we need something different that is called the chain rule. In this case, here is x, but x is function of this one. Okay?
Yeah.
So we are taking derivative dy dx, but take the derivative with respect to dfx and dfx. This way. Then they are
Cancel.
cancelled out. Okay? Then what is this part? Y equals fx squared. You can think this fx as large x. And take derivative with respect to large x or fx. What is the result?
2 large x.
Yeah, 2 large x or 2 fx. Okay?
Yeah.
2 large x is just correct. Times, what is this one? This one is 2x plus 1. Let's take derivative with respect to x. What is the result?
2 2.
2. This is chain rule. Okay? When the two functions are combined, here's one function, another function. Then think about this one as big X or big f of x. Then you can take derivative of this one 2 times entire thing. Okay? 2 times fx. Okay? And you need to take the derivative of fx, only fx, with respect to x. Okay? So in this case, what derivative of this one? dy dx. Okay? We are taking derivative with respect to x, but x, there is another function. Then how do we take derivative? Let's take derivative of this entire thing with respect to 2x plus 1. Okay? Then what you get is 2 times 2x plus 1. This is the first part. Times this inside function. Let's take derivative with respect to x. What is the result?
2.
Okay? This is chain rule.
Okay.
Okay? When you see this kind of structure, take the derivative with respect to this entire something square, then you will get 2 times entire function, this part. And then take the derivative of this one with respect to x one more time and multiply it. Okay? This one requires some practice. When y equals 3x plus 2 square dy dx is what?
3 times.
2 times.
Oh, okay. Alright. Yeah. 2 times 3x plus 2 multiplies 2. No, 3. Yeah.
Okay?
Fine.
When y equals 4x plus 2 square, what is dy dx?
It's 2 times 4x plus 2 multiplies 4.
Good. That's chain rule. So you need to memorize, practice it again and again and again. In OLS, this is required.
Okay.
So I finish it up to the chain rule. So OLS, the purpose is minimizing sum of squared residuals. Okay? Then yi equals alpha plus beta xi plus epsilon I. This is our data generating process. The residual is epsilon I equals yi minus alpha minus beta xi. Okay? Our objective function is yi minus alpha minus beta xi square. This is residual. Squared it, sum it, and minimize it with respect to alpha and beta. Okay? What is it? The characteristic of the minimum or maximum is that this is not sufficient condition but a necessary condition. But anyway, intuitively, at the maximum, the slope of the line is 0. Okay? At the minimum, slope of the line here is also 0. It means that this is some kind of minimum. At the minimum, when you take derivative, the derivative equals 0. This is not a sufficient condition but a necessary condition. But in OLS, that's not that important. Okay? Mathematically, I need to teach a way more. But at the minimum, in many cases, the derivative equals 0. There are some exceptions. Forget about the exceptions. Okay?
Okay.
So we are trying to minimize it with respect to alpha and beta. Okay? Then here we have two variables, alpha and beta. So we use partial derivatives. Okay? So do the partial derivative, summation I equal 1 to n, yi minus alpha minus beta xi square. Let's take partial derivative with respect to alpha. And this one equals 0 at minimum. Another thing is that yi minus alpha minus beta xi square. Let's take partial derivative with respect to beta. This one equals 0 at minimum. Okay? Then here we need to use the chain rule and partial derivative at the same time. Okay? So at this moment, forget about this summation. Okay? You can forget about it. There are some conditions that you can forget about the summation and sometimes you are not. But in this case, you can forget about it. Okay? In a higher level, when the point is at the boundary, you cannot forget the summation kind of thing. There is also the exception of it. Forget about those kinds of things. Okay? Then, when you take the derivative of this one, here is summation. How do you do the derivative with this one? This one is this entire thing square. So what you get is 2 times yi minus alpha minus beta xi. The first one. Entire thing square. So 2 times entire thing. Okay? And we are taking derivative with respect to alpha. So you need to take derivative with respect to alpha. What remains here is negative 1. Following?
Negative 1, yes.
Okay. 2 times entire function,
Mm.
and inside it you have negative alpha. Take derivative with respect to alpha.
Yes.
This one equals,
0.
okay. This one, summation I equal 1 to n. We are taking derivative with respect to beta. Then the result is 2 times yi minus alpha minus beta xi up to here the same. This entire thing square 2 times entire thing, and you are taking derivative with beta. What remains is negative.
Negative xi.
Good. Okay. So I generally call it 2 normal equations. Okay.
Mm.
Basically, in mathematics, this is the first order conditions of OLS. Okay? First order condition means that at the minimum, the necessary condition equals 0. Okay?
Mm.
Second order condition is the sufficient condition of minimum, as I remember.
Mm.
But anyway, at your level, don't worry about those kinds of things. So my favorite author, Professor Madalla, he called it first 2 normal equations. I like that notation at the same time. So these 2 things. Okay? Then here, I can divide both sides by negative 2. Okay? Then 0 divided by negative 2, that is still 0. 2 times negative 1, negative 2, I can cancel it. Okay?
Yes.
Then this kind of summation is, I can distribute it. Okay? So what you get is summation I equal 1 to n yi. When you add up alpha n times negative n times alpha. Are you following this one? Okay? Minus beta summation I equal 1 to n xi equals 0. Okay? In this kind of summation, when something is indexed, this one should be here. But this kind of beta is the same. It is constant. So you can factor it out. Let me give you the example. Summation I equal 1 to 3 xi. This one is x1 plus x2 plus x3. Question? This is notation. Okay? Summation I equal 1 to 3 alpha. This one is alpha plus alpha plus alpha, 3 alpha. Okay? Summation I equal 1 to n beta xi, 1 to 3. Beta xi, beta x1 plus beta x2 plus beta x3. Okay? I can factor out beta x1 plus x2 plus x this way. Beta times summation I equal 1 to 3. That is what happened here. Summation negative beta xi. Beta is not changing. You can factor this out. Xi is changing from 1 to n, then this way. Question?
No.
Okay. In this case, I can also delete this 2 and -1 by dividing both sides by -2. Here, we need one more step. yi times xi. You need to calculate this part first. Negative alpha xi minus beta xi squared equals 0. Then summation I equal 1 to n yi xi minus alpha summation I equal 1 to n xi minus beta summation I equal 1 to n xi squared equals zeta. This way. So you have two normal equations. Okay? Then, what I taught in my last class, two equations and two unknowns. Equation number 1, equation number 2, two unknowns are alpha and beta. Two equations, two unknowns, it has one solution. Okay? That is the same. So let's do that. So that is kind of theoretical derivation. Mathematical derivation is, let's think about 3 examples. x1 equals 0, y1 equals 0, x2 equals 1, y1 equals 1, x3 equals 2, y2 equals 2. We have 3 data points. Here's x, here's y, first point, second point, third point. Okay? This is our data set. We are trying to do is the line fitting. Okay? Then how do we do this kind of thing? OLS is the minimizing sum of squared residuals. Okay? This one, these are the two normal equations or two first order conditions of OLS. Equation number 1, equation number 2. There are two unknowns, alpha and beta. Then we can solve this system of equations. Okay? How do we solve this one? Basically, the first one requires summation of yi. Okay? And in our case, we have 3 observations, n equals 3. This one requires summation of xi. Okay? Then, what is summation of yi? Here, our n equals 3. What is summation of yi? y1 plus y2 plus y3. In terms of number, 0 plus, I'm sorry. I need to write it down as 3. Okay? Otherwise, I cannot do that. Yeah. y1 plus y2 plus y3. This is y1, y2, y3. That is 4. Equation? Okay? So this is our normal equation. I gave you the 3 data points in terms of example. First one requires summation of yi. Okay? N equals 3. Next one requires summation of xi. Okay? That is x1 plus x2 plus x3, 0, 1, 2. Okay? Then it means that the first equation, when you have these 3 observations, the result is summation yi, that is 4, minus our n equals 3 times alpha minus beta times, what is this one?
3.
This is our equation number 1 when we have 3 observations. Okay? Question?
No.
For equation number 2, what we need is summation xi, yi times xi, this one. How do we calculate? Summation I equal 1 to 3 x or yi, that's how I write down, yi times xi, okay? This one is y1 times x1 plus y2 times x2 plus y3 times x3. Okay? What is y1? 0. What is x1? 0 times 0 plus x2 times y2. Y2 here. Okay? This one times this one. 1 times 1 plus y. Oh, what am I thinking? y3 times x3. 3 times. Okay? This number is 0 plus 1 plus 6. Okay? This number is 7. We know this value. What we need is this one. Okay? Summation I equal 1 to 3 xi square. This one's x1 square plus x2 square plus x3 square. Then 0 square plus 1 square plus 2 square, that is 5. Okay? Then our second equation is, this is 7 minus alpha times, what is summation xy? I think that is 3. Minus, what is it? Beta times xi square is, I guess, 5.
5.
Yeah, equals 0. This is our second equation. Okay? This one is 7. And this is 3 times alpha. 2 equations, 2 unknowns. You can solve this one. Let's solve it by using matrix this time. Okay? In the previous days, I did not teach matrix. This time, I taught the matrix. So let's solve it with the matrix. Okay? Advanced course does help. Okay. Then what you have is something like 3 alpha plus 3 beta equals 4 here. First one. The second one is 3 alpha plus 5 beta equals 7. Okay? 2 equations, 2 unknowns, alpha and beta. Any question up to here? Then, in terms of matrix, 3, 3, 3, 5, alpha and beta, 4, 7. Okay? Then, what is the next step? We need inverse. Also, pre-multiply 3, 3, 3, 5, inverse 4 and 7. Okay? Then what is this one?
1.
Identity matrix.
Mm.
Okay?
Mm.
So this one becomes 1, 0, 0, 1 this way, and alpha and beta. 3, 3, 3, 5, inverse, 4 and 7, I guess. Okay? Then this one times this one, just alpha and beta. Okay? Identity times some matrix, original matrix. Question?
No.
How do you calculate this one? AD minus BC. Okay? 3 times 5 minus 3 times 3. This is determinant. Okay?
Negative
A
5.
and D, they change their position. Negative 3, negative 3, 4 and 7. Okay? Then what is it? This is 15 minus 9, negative 6. Oh, just 6.
6.
When you calculate this one, 5 times 4
20.
minus 3, 7. Okay? This part, negative 3 times 4 plus 3 times 7 this way, I guess. Okay? Then, what is it? 20 minus 21, negative 1. 12 plus minus 12 plus 21, I think that's 9. Okay? The result is I multiply this number, both of them, negative 1 sixes, and 6 divided by 9. This is value of alpha. This is the value of beta. Okay? This is how we solve OLS. Okay? So when you have the problem with this kind of matrix operation, practice. Okay? Practice and practice and practice. Now you learned matrix and I reviewed this kind of thing. So try to think it in this way. So when you use theta and when you run OLS, what theta do is this one. It calculates this one, this one, this one, this one, and this one, and solve the system of linear system of equations. Then it will get this value and this value. Okay? What will theta do for you when you run OLS is they have this kind of command, or like there, calculate these values and do this one, and they will give you this number and this number. Because this is relatively simple, the operation time is very short. It's not a very difficult process. Okay? So when you operate theta, in case of the theta, general command is reg. This one is run a OLS regression. Okay? Then, what is it? In this case, what we have? Y equals alpha plus beta xi plus epsilon I. Then we put y as dependent variable and x. That's it. So in case of theta command, you will use this kind of command. Regressive, this means that do OLS. And y, that means that we have this kind of structure. Y is dependent variable, this one. Okay? Then this alpha is generally assumed. You don't have to write it down. And x is control variable. Okay? and epsilon I is also assumed. Then it will give you the value alpha equals this one and beta equals this one automatically. And it will give you other kind of statistics. Okay? I will talk about that later. But when you have this kind I deleted my data, but 3 data set, you will have X and Y, okay? Then run stata command, you will get this one. This is how the things operate inside stata. Okay? So practice this one. Think about that X equals homework, X equals 1, Y equals 1, X2 equals 2, Y2 equals 2, X3 equals 3, Y3 equals 4. Please do the same calculation by using matrix. Okay? My recommendation, follow everything. From the OLS derivation, derive these 2 normal equations, okay? And then use these examples, calculate those values, do matrix operation, calculate this one. Okay? Question? Okay, I think I can stop today's class here. So, we will see. I will see you guys.
4
Can you change it to 2 p.m. something like that? Is it possible?
Sorry?
How about 2:30? Is it possible?
It's 2
2
something.
你不睡觉
我无所谓，看你主要看你的啊，所以你的时间定，你按你时间定。
？OK OK。
So 2:30 is okay?
Or 2:30?
我本来想4点了睡会儿，这个肯定睡不醒了。随便了，没听他的，反正讲。2:30。
2:30? Okay, see you guys at 2. I have a meeting at 4 p.m. So I need to attend it.
Okay.
So, but and it was very kind of important meeting. Okay? So see you guys at 2:30 today. Okay? I will teach something related to this one and some kind of advanced thing. But try to do your homework. If you have done it, make it one more example. Okay? 1, 2, 3, add another, do all these kind of things. Okay? Then after this one, I think I will teach something different. Okay? Okay, see you guys at 2:30 p.m. today.
Thank you, sir.
See you.